Aluminium forgings emerged about 60 years ago, starting in the aerospace industry. Today, their use has rapidly expanded across various fields, offering versatile benefits. In the transport industry, aluminium forgings are prized for their weight savings. This translates to significant fuel consumption reductions, making them an eco-friendly choice. The advantages of aluminium forgings include high strength-to-weight ratio, excellent corrosion resistance, and optimized fiber structure for enhanced fatigue properties. The fundamentals of the forging process involve changing cross-sections and adapting material properties through methods such as material displacement and accumulation. Processes like bending and shear forming are essential in changing the direction of materials in forging. These techniques shape the metal for various applications. Creating hollow spaces in aluminium forgings is achieved through indentation forming and extrusion forming methods, adding functionality to the final product. Cutting processes, particularly shear cutting, play a crucial role in separating raw parts into defined lengths and sections for successful forging. Die forging processes ensure that aluminium parts are produced with precise geometry and volume accuracy, critical for maintaining product integrity. Open die forging allows for flexibility in shaping larger aluminium pieces, offering diverse options for manufacturers in crafting their products. Different characteristics of die forging highlight its efficiency in producing high-accuracy components, essential for the industry. There are various special die forging processes. Various aluminium alloys, especially heat-treatable ones, are suitable for forging, ensuring structural integrity while meeting diverse engineering demands. Pure aluminium, with limited strength, is often alloyed to enhance its properties, providing high-strength materials with tensile strengths above 600 and on ABM for rigorous applications. Thanks for watching.